research of X-ray stress measurement as a measurement researcher. I'd like to say about our newly developed triaxial stress measurement. And
closer to the mic.
And I want to say that I want to obtain your opinions about our X-ray machine, whether it is effective or not for the application for monitoring the RCF phenomenon of rays. So please give me your opinion and comments in this occasion.
Okay, thank you.
Yes, so as I showed my presentation, so I to investigate the transverse crack growth rates in railhead. So I conducted two types of tests, such as CT test and rail bending test. This is the result. And the effect of heat rate is small and the residual stress is big. The crack portion affects the depth of break. Thank you.
Today, I presented the initiation of cracks. And the phenomenon of wear development or crack initiation is mainly caused by the rolling contact between the wheel and the rail. Therefore, the exact contact condition, to calculate the exact condition, multi-body dynamics is very useful. However, the assessment of the wear development and the initiation of cracks is needed to the exact equation. Thank you very much.
Thank
you. So as you saw in my presentation, the main approach there is to have a systematic approach to analyzing RCF and to build up a database of RCF cracks for multitude of rails, and then have that information being useful for people with boots on the ground who are doing the grinding and for people who are doing the mathematical modeling.
So we have time for questions.
I have a question for Daniel. Very excellent work.
Thank you.
We know for the high rail in the tie curve, there are lots of metal removal. So you would suggest new patterns, ID current sensor patterns. So I mean, when you suggest these patterns, what do you thinking is applicable for what kind of metal removal? Like say just what for your case or for very severe metal removal as well, or?
Yeah, so so far we analyzed only rails that are from heavy axle loads in North America. So we developed a way to slice those rails in this orientation to have the best available information for the crack morphology. But I think that your question is, if you have cracks in different orientations, how do you cut them?
If we have very severe metal removal at the gauge corner, so is your pattern applicable or not?
In the rails that we looked at to date, those cuts are good enough to address that, yes. But if we need to modify the cutting planes to add some additional cutting planes, we can definitely do it in this model. And then collapse that information to the position of the crack initiation for comparison, right?
Dan, this question is for you, and it relates to the eddy current technology. We've been using that now for about 3 or 4 years, both in a combination of a walking stick and also on a high rail vehicle, so we can operate at a higher speed. And every time I hear these presentations, I feel frustrated in a way, because I know there's definitely an issue about the crack length versus the crack depth. However, compared to the years ago when we were doing our work with no technology, no readings, we feel that there's a huge amount of benefit and value. And my concern is that it seems like the message I get at times is that, you know, we have a bad situation because the angle isn't known and we don't know for sure what the depth is. And I'm not denying that, but we've certainly got a lot of benefit out of that. We use it every day. And we also have another comment that relates to this, and that is if you really are wanting to implement true preventive magic wear rate grinding, then the argument goes away, because if you're removing the cracks, there's no difference between the length or the depth. So we feel that it's a huge improvement, and I'm hoping that over time that we are not going to keep hearing that concern. Not that we don't want to do that, but I think that could become something that is not as negative as what I kind of hear the message.
So to answer that, I would say I feel your frustration, but don't worry, because what we're doing here is we're optimizing the removal rate for improvement in rail life cycle. That's all we're doing. You're absolutely right. If you can measure it and you can go out and then grind it off and go back and do the post-grind measurement and not see anything, you have done your job, right? So there's no question, no argument there. What we're trying to do is we're trying to optimize that removal rate so you're not removing more than you have to. That's all we're doing here. So.
Next question.
I have a question for Masahiro.
Yes.
If you compare crack when you get head checks on the low rail compared to the high rail, would you say that you get more plasticity on the low rail when crack starts to form than you do on the high rail?
Sorry, I don't know. I didn't have confirmed. But I think plastic flow was very, about the plastic flow, it is, the value of plastic flow will be higher than in low rail.
Yeah, you see quite a lot of plastic flow on a low rail when you get the cracks, right? So you have a lot of plastic deformation on the low rail. So the cracks are formed due to high plasticity, high plastic flow.
Mm-hmm.
Would you say that you have more plastic flow on the low rail when you get cracks than you have on the high rail when you get cracks?
I think it is higher in high rail, better than
Higher in high rail.
high rail.
Thank you.
Do you have more plasticity on high rail?
Yes,
Is that right?
maybe.
Maybe, you're not sure. Okay. That's the question. It was a question in the middle.
Thank you. So I have a question to Daniel. So I want to ask the real samples that you have chosen, are there, so those are, I suppose that those are the rails who face severe cracks, and where are they coming from? Can you just summarize shortly?
So those rails came from the heavy axle load in North America, so from Canadian National, from Norfolk Southern, and from BNSF lines. So all loads with an axle load of about 39 tons per axle, and all the rails were at the end of the life cycle. So whenever we collect those types of samples, the collection is very opportunistic. So we need to go in and take what's available.
Sorry. So my question is that, so are they coming from kind of, for example, straight sections in tunnels, bridges, or whatever, transitions next to joints?
I don't think that any of them are from bridges. There's no tunnels. It's just open track. The ties are wooden ties, heavy axle load, just from general environment, all over US and Canada. Was that, sorry?
Narrow curves?
Curves? Oh yes, absolutely. As I've shown in the presentation, from tangent to a curve of 368 meter radius curve.
Okay, thanks.
Richard, next question, please.
I only have one or two remarks for Daniel. So, in North America, we define the curvature not in radius meter, but degree of curvature. So it might have been useful to show this in your table, the conversion.
Yeah, it was there.
Well, the first one, we might have
Second
overlooked
one,
it.
yeah, I'll fix that. Yeah.
But that might be helpful because that always gets some confusion. And the second thing is a little bit for Gordon. In Europe, with respect to eddy current technology, German railways have done a lot of research before they came up with certain angles to represent their damage conditions at the gauge corner. Yeah? So I think you're on a very good path to do similar work for North America, because we've seen that North American damage conditions can differ quite substantially from what we see in Europe, and that's why what we learned in Europe with respect to the angle that you need to apply does not work in North America. And I think one of the keys will also be then to have this technology also on the maintenance machines in the future that might help you to even further define your angles. So
That's
it's more
great.
like a statement than a question.
Sure.
Thanks.
Well, all this is published in the paper, so I invite you to read the paper, and if you have any comments, my information is there. Please email me and let me know, if this research can be improved. Thank you.
We have more questions.
Just general comments for third speaker. You divided height check into two types. One is continuous type, one is discontinuous type. I just wonder the discontinuous type, just the squat, not the height check. So what do you answer for this? So you divided height check into two types. One is continuous, one is discontinuous. But for me, the discontinuous height check is just a squat, it's not the height check. So I'm not sure my understanding is wrong or your understanding is wrong. Yeah.
ヘッドチェックじゃないです説明。
はい。
Yeah, it's very good, very good. Thank you. Yeah,
ラリアちゃうと違うの。
take it in Japanese, and then we can discuss it.
According to the cross-sectional observation, the cracks propagates the opposite direction to train running. About the rail scores, it propagates towards to the train running. It's caused by the rolling contact in addition to the water pressure. So I think the head check and the rail squats not the same propagates the direction of cracks.
Not clear, but maybe we can leave it for.
Direction of propagation is different.
Yes.
Different. The Scott is just going on the same direction of the truck and the vehicle, and such a head check is just opposite side.
Yes.
A little bit question.
Okay, maybe we can leave the discussion for coffee break and come to the next question.
Hi, Daniel. Hello? Is the microphone on? Yeah. Yeah. Quick question for Daniel. Well, it's not really a quick question, but it's also a question I want to direct to the rest of the room. So I'm interested in the morphology of the cracks on the top of the rail in some of the samples that you showed. They're quite unusual, and I don't think I've seen them like that before, and I don't know if anybody else in the room has seen them like that before. Have you got any theories as to why they grow in that particular orientation, i.e. straight down and quite erratic?
Based on my experience, the crack, they start based on the angle of attack, especially in the curve. So as the wheel comes in and it's attacking in a specific direction, that's where you get that first line, and the preferential plane of growth is down in that direction. That's at least true for North America. I'm not sure, Richard, if this is for Europe.
Excellent. Thank you very much to all of you for all interesting questions and answers.
Thank you very much.